Okay, team, I just did a different video where I was using the same material and we were talking about the difference between a molecular formula and an empirical formula. Um, Go to that if you want those details. I'll just summarize and say there are times in chemistry where we are delivered to us information about mass, and to be a functional chemist, often we need to get this into information about numbers. How many hydrogens are there relative to carbon and so on? That helps us do our chemistry on paper. So here's another example problem. The only difference between this one and the previous one is that this time I'm given the mass of the sample. You would be totally fine if your only goal is to find what is the empirical formula. You would be totally fine to still assume 100 grams. And so I would start my problem by saying I have 38 grams of carbon, 51 of oxygen, and 9 and change of hydrogen. This time around, I'm going to use the initial mass information here. The reason why I might do that is because sometimes there might be a more complex problem happening in the background. We will soon do problems that we're going to call combustion analysis problems. Those are times when I might want to know the actual mass of my particular sample. And so let's just roll using the 4.92 grams that we are given in this problem. So I have carbon. I'm going to put my carbon over here. I have oxygen and hydrogen. Remember, chemists tend, if given the option, tend to put more electronegative things at the back. And so I've reordered these. It doesn't make it wrong if you don't do this step, but this is just what a typical kind of chemistry situation might call for here. So carbon. So instead of assuming 100 grams, I'm going to use this information. I've already pre-calculated this just to save a little bit of time. But what is 38.7% of this 4 number? It comes out to, let me put those down. It comes out to 1.90 grams of carbon. I'm going to be really good about saying grams of carbon as opposed to moles. Again, in those more complicated problems, sometimes you're going to want grams, sometimes you're going to want moles, and I'm just going to make sure that I'm good about writing it down so that if in a different problem, if I ever needed to grab one of my numbers, I make sure I grab the correct one. All right, so again, what is 9.7% of 4.92? It's right here. And then my last one is going to give me 2.54 grams of oxygen. Sometimes I write a little X on my keys right there, OX for oxygen. I know that's not the symbol, but I don't want it to look like a 0. Okay, now I need to get from my mass information over to a number, and that's where I use molar masses. You need to use the correct molar mass for each one of these things. So I'm going to be using 12.01 for carbon. I'm going to be using 16 for oxygen and 1.008 for hydrogen. But nonetheless, we are dividing by molar mass. And I have these pre-calculated as well. This is going to be 0.158 mole. So again, mole carbon. This is 0.475 mole hydrogen, and this is 0.158 mole oxygen. Now, again, this is the correct ratios for my particular problem. So in a different world, not the world we are in, but in a different world, this would be the correct empirical formula. For, trying to do 2 things at once here. This would be the correct empirical formula for this particular compound. We prefer to use the smallest whole numbers, and so this last step, divide by small, is just a math trick basically to rescale these numbers. We're dividing by the same number every time so that we maintain the correct ratios. But dividing by small is going to leave this to be a 1, that to be a 1. Plug in this divided by that, or this divided by that, into your calculator, and you're going to find that it's a 3. So my empirical formula is C1H3O1. Chemists tend to leave out the ones and just let it be implied. CH3O. Now, in truth, when I wrote this problem, I was basing it off of this particular molecule, or something that has this actual molecular formula. This is as far as we can get with the given information. Sometimes a problem might ask you to go to a molecular formula, but if you were to do that, you would have to have some additional information that we do not have in this problem. So that's where we need to end. All right, hopefully that worked for you.